Welcome to Saxon Algebra 1. This is Lesson 2. We're going to start talking about a little bit of geometry today. We're going to begin with intersecting lines. Now, we've previously discussed that a line is a straight path that goes on and on in opposite directions indefinitely. When you have two of these and they intersect or cross, we call those intersecting lines. And the place at which they cross, we call the point of intersection. Now, when two lines intersect such that there is a 90-degree angle formed, it also forms four total 90-degree angles. And the reason for that is a straight line is a straight angle, and that equals 180 degrees. So when you cut that exactly in half, you're going to get 90 degrees all the way around on the top and the bottom formed by the two lines. And we call that specific occurrence perpendicular lines. Now, when you have two intersecting lines where it's not exactly cut in half, it's not exactly 90 degrees, you get what's called an obtuse angle on one side, which is going to be greater than 90 degrees, and an acute angle on the other side, which would be less than 90 degrees. And it has to happen that way because your straight angle of 180 degrees, this has to equal 180 when added together. So if this one is greater than 90, 180 subtracting that amount will leave you less than 90 on the other side. Another thing to mention is that when you have two intersecting lines, you get congruent angles opposite of each other. So whatever the measurement of this angle is will be the same measurement opposite or just across from it. It's like a mirror image across this point of intersection. And the same thing here. Your acute angle measurement will be the same measurement on the other side across from it here. So we can illustrate that with, let me get my pen. We can illustrate that by saying that this measurement here and this measurement here are the same, and then this measurement here and this measurement here will be the same. And we indicate that with tick marks. And the same number of tick marks here gives you the information that these are the same measurement. So look for the number of tick marks, and wherever they are the same, you have two here and two here, so that degree of measure is the same. One here and one here, that degree of measure is the same for both of those. And that is the general rule. It's the way it works for intersecting lines. Now, as I previously mentioned, a straight angle is just simply 180 degrees. So we know that a straight line or a mathematical line also measures 180 degrees. Now, we say that no angle will ever measure more than 180 degrees, and the first thing that I know pops into your head is the same thing that popped into mine. I wanted to say, what if I drew an angle that looked like that, and this was the degree of measure? Well, that is the degree of measure for the exterior angle. We never classify an angle by its exterior measure. We always classify it by its interior measure. And that is why it can never be more than 180, because once you start to go back the other direction, then we start to measure the inside. And the outside, it becomes, mathematically difficult. It's a lot easier to deal with smaller numbers when you're doing calculations. So we want to use the smaller measurement. It still gives us the same angle. It's just easier to calculate and to reference. So it's always going to be 180 or less for the measurement of an angle. Now let's talk about polygons. Polygons are an enclosed shape with flat sides do not cross. So we have 6 shapes here, and we're going to discuss which ones are and which ones are not polygons. We have this hourglass or two triangle type shape, but we have these two lines that cross. So that immediately tells us this is not a polygon. In this shape, we have an opening. It's not enclosed, so this is not a polygon. And in this shape, we have an enclosed shape, and it doesn't have lines that cross, but we have a curve here. So this is not a polygon. And in understanding that a curve is not part of a polygon, we know that a circle is not a polygon as well. Now down here we have a shape that has 4 lines that are flat, and they all join at corners and they do not cross. So this one is a polygon. For this shape, we again have several lines or several sides, and they all connect at corners. They do not cross, and they're completely enclosed. So this, and there's no curves. So this is a polygon. And again, we have 3 sides here, all flat, all connecting at corners, and they do not cross. So this is a polygon. Let's talk about the names of polygons. When we have a polygon with 3 sides, we call that a triangle, because when 3 flat sides meet, it forms 3 angles. 1, 2, 3. That's why it's called a triangle, because tri means 3. Now when we have a shape with 4 flat sides, we call that a quadrilateral. Lateral means side, and quad means 4. So a quadrilateral has 4 sides. A pentagon. Gon comes from the same word that means shape, where we get the word polygon. And penta just means 5. So a 5-sided shape is a pentagon. A hexagon is very similar to a pentagon. And once you get 5, 6, 7, 8, they're all going to have gon on the end of them to represent that they are a flat-sided figure or a shape. So hex means 6. So this is a 6-sided shape. Now there are 2 different types of polygons, and they are either concave or they're convex. Now I like to remember the difference because concave has the word cave in it. So if your polygon makes a type of cave, if it points toward the inside at any corner, that's going to be a concave shape. And the way you can test for a concave shape is to draw a diagonal line from one corner to another corner. And if that line crosses another of any of the exterior sides, then it's concave. And in this instance, we can draw that line twice from corner to corner and corner to corner, and then we get 2 crossings of the exterior of the shape. So this is concave. We can do that to this shape, and we can see that none of the lines go across the exterior of this shape. We can continue to draw diagonals, and none of these diagonals, if I can actually draw them correctly, here we go. None of these diagonals that go from corner to corner inside cross over the outside into the outside of the shape. So this shape is called convex because every corner presses outward. With a concave, you have corners that press inward. So use the diagonal test. If you can go from every corner to every other corner that's opposite it, and you don't cross the exterior of your shape, then it's convex. If any one line crosses, any one diagonal line crosses the exterior of that shape, then it is concave. Okay, so those are your 2 classifications, and then you have the names based on the number of sides that they have. Now let's talk about measurements, and we're going to classify their measurements as either having equal sides or equal angles. If they have equal sides, we call that equilateral. An equilateral polygon is where the polygon has all sides the same length. Lateral means sides. So we have an indicating tick mark here that tells us that all of these sides are the same measure. When you see a tick mark on a shape, that's what that means. So all of these lengths are the same. So if I were to tell you that this length was 6, And I've got my shape still on. If I were to say this side measures 6 inches, then the tick marks would tell you that all the sides measure 6 inches. The same for this square, all the sides are the same, and the same for this triangle, all the sides are the same length. So if one side was 10 centimeters, both of these other sides would be 10 centimeters because you have that visual indicator that tells you that. You don't have to actually pull out a ruler and measure it. Now, an equiangular polygon is where the angles all have the same measure. And a good illustration of that is this quadrilateral rectangle. A rectangle is a quadrilateral that has two pairs of sides that are the same length. So we have two this way and two this way that measure the same thing. And we could indicate that as well by putting tick marks here. Those two are the same. And these 3 tick marks here would indicate that those are the same. And then the tick marks in the angles would indicate that all the tick marks have the same measure. Same thing with this triangle. We see that all of the angles have the same degree measure. Now, what if both the sides and the angles are the same? We would call that a regular polygon. And a good example of a regular polygon is a square. In a square, you have 4 90-degree angles, and all 4 sides are the same. Now you can see in a rectangle, all 4 angles are 90 degrees, but you have 2 different lengths and 2 different heights on your rectangle. With the square, they're all 4 the same. So that's the difference between this quadrilateral and this quadrilateral. In an equilateral triangle, all 3 sides are the same, and that forces all 3 angles to be the same measurement as well. That's just the nature of triangles to work that way. So let's talk about triangles specifically. When you have an equiangular triangle and all the angles are the same, it also has to be an equilateral triangle. That is the relationship that triangles have that are unique in the polygon family. You cannot have a triangle where all 3 sides are the same, where the angles are not the same. The angles have a direct relationship to the sides. And that degree measure in an equiangular triangle is going to be 60 degrees because a triangle always has a total interior angle measurement of 180. So 60 plus 60 plus 60 is 180. It never changes. You can never have a different measurement of your interior angles of a triangle. So if they're all equal, it's 180 divided by 3, which is 60, because you have 3 angles of measure. In a right triangle, one angle is going to equal 90 degrees, and only one angle, because 180 minus 90 leaves 90. And the other 2 angles have to split that 90. So these could be 45 each. They could be 60 and 30. It could be whatever equal these 2 added together would be 90 degrees. So if you know you have a right triangle and you are given the angle of the degree here, you can mathematically figure out what the angle of degree is here. And also about a right triangle before I move on, the leg that is opposite the 90-degree angle is called your hypotenuse. And only a right triangle has a hypotenuse. And the hypotenuse is the longest leg in the right triangle. And there's a special formula to figure that out, that measurement. It has a special relationship. We'll get to that later. An obtuse triangle is going to have one angle that is greater than 90 degrees, and the other 2 angles are going to be acute. An acute triangle, on the other hand, has all angles less than 90 degrees. And if you're thinking what I'm thinking, an equiangular triangle is also acute because all 3 angles are less than 90 degrees. Now, an isosceles triangle is a triangle that has 2 sides of the same length. And when you have 2 sides of the same length, you also create 2 angles that have the same degree of measure. That is just the nature of having those two legs the same. Now, the angle created by the two legs that have the same degree is going to be your different one. It's going to be the one you have to figure out. And the length of the leg opposite that unknown angle is also the one that has to be figured out. So you can draw a straight line from the unknown angle to the leg of this angle. And sometimes an isosceles triangle is also a right triangle, just for reference. Now, a scalene triangle is where you have all three sides different lengths. And because all three sides are different lengths, all three angles are going to be different degrees of measure. Remember, the main thing that you need to put in your notes when we're talking about the degree measure of a triangle is that the interior angles of a triangle, all added together, will always be 180. You can always say 180 minus whatever you have inside that you know, and that will give you what you don't know. So let's do some practice problems and figure these out. Let's start with example problem 2.1. All right, we are given a triangle here, and it looks like it is a scalene triangle. And we are told that this degree of measure is 130 degrees. And we don't know what x is, but we know that this one is 30 degrees. So we are told to find the degree measure of x. So we know that the interior angles of a triangle always equals 180. So we can say 180 minus 130 minus 30, and that should equal x, because all three of these should be 180. Now 130 minus 30 is 160, so 180 minus 160, that's going to be 20. So the degree measure of x is 20 degrees. Okay. 2.2. We have to find x and y. And we are given, let me get my shape. We're given a scalene triangle. Okay. And that means that this is the same and this is the same, which means that this will be the same and this will be the same. And this is y and this is x. And we are told that this is 50 degrees. Well, if this is the same as this one, then x equals 50 degrees. We don't have to do any math on that one because we know in a scalene triangle that these two are the same degree of measure. So now that we know that x is 50 and we already have a 50 in here, the known total of angles is 100 because 50 and 50 is 100. So we have 100 degrees already. So we are going to subtract 100 degrees from 180. So 180 minus 100 equals 80 degrees, and that is what y. So that equals y. So this one is 50 degrees, and this one is 80 degrees. Okay, let's do example 2.3. Now in 2.3, we are asked to find x and y, and we are given this triangle here. Okay, and we are told that this side measures 8 and this side measures 8, and this angle is 110. Okay, so if this side measures 8 and this side measures 8, then that means that this is a scalene triangle. I'm sorry, an isosceles triangle, because these two legs are the same. Well, if these two legs are the same, then these two angles of measure have to be the same. So what that tells me is that we can subtract 110 from 180, and that leaves 70, and we have to divide that equally between these two because these have the same measurement. So we divide that by 2, and that is going to equal 35. So this angle of measure is going to be 35 degrees, and this angle of measure is going to be 35 degrees because 35 plus 35 plus 110 equals 180. All right, do we have another example problem? We do not. But we do have a little bit about quadrilaterals. So let's talk about that for just a moment. If you need to write these example problems down, do so now, because I'm going to clear the page. Pause and write it down, and then I'm going to clear the page. So with quadrilaterals, we remember that a polygon with 4 sides is what that is. And we have 5 different types that we want to talk about. So the first type that we have is a parallelogram. And a good example of parallelogram, sometimes that's hard to say, is a rectangle, but also a rhombus. And a parallelogram is just a quadrilateral that has 2 pairs of parallel. The sides are parallel, so it has 2 pairs of sides that are parallel. So this side is parallel to this side is parallel to this side. Also, the measurement of this side and this side are the same, and the measurement of this side and this side are the same. Then we have what's called a trapezoid. And a trapezoid has only 1 pair of parallel sides, and the other 2, if they continued, would eventually intersect. A rectangle is a shape that has, let me see if I can do that a little bit better. That's a pretty poor rectangle. Let's see. A rectangle has 4 right angles. That is the definition of a rectangle. So by that definition, a square is a type of rectangle, but it's a special rectangle that has also got the 4 sides the same, and we've already talked about that. Let me go ahead and label these for the sake of you being able to take better notes. So that's a parallelogram. This is a trapezoid. This is a rectangle. And we also talked about a square, and a square is simply a rectangle that has the 4 sides the same. So all the degree measures are right angles, and all 4 sides have the same measurement, and that is a square. And there's one more type of parallelogram, and that is a rhombus. And a rhombus is a shape that has all 4 sides the same length, but it has 2 sets of measurements in the angle. So you have these 2 are the same, and it has these 2 that are the same. So it's like a square that has been slanted. So you know that all of the sides are the same length, but it's been kind of slanted or skewed to one side. So you're going to have 2 angles that are obtuse that are the same, and 2 angles that are acute that are the same. And that's how you know it's a rhombus. All right, and that is all I have for lesson 2. I will see you in lesson 3.